Today we're going to talk about inequalities for two triangles. This is our topic. Okay, so last time we talked about inequalities for one triangle. Now we're going to look at the inequalities for two triangles. So that's our topic today. And let's start with this one here first. Take a look at these two figures. If I have two sticks like this, AB and BC and ED and EF, and notice that AB is length of AB is 8, ED is 8, BC is 9, EF is 9, right? And if the angle right here it forms, angle B is greater than angle E, what can you conclude about AC versus DF? I bet a lot of you could, oh, that's sort of easy. If angle B is greater than angle E and then these two sides are congruent, right? What can you tell me about the length of AC versus DF here? Andrew?
AC is greater than...
How many people agree with Andrew that AC is going to be greater than DF? That's sort of obvious, isn't that right? And it's obvious because you know that AB is congruent to what? ED and BC is congruent to EF, isn't that right? So the conclusion is, of course, AC will be longer than DF, of course, if angle B is greater, right? So that's what our first theorem is. Okay? So let me show you what's given and what to prove here. So look, that's our first theorem. If BA is congruent to ED, BC is congruent to EF, and angle B happens to be greater than angle E, we know that side AC is greater than DF. That's it. Very simple. Right? It's sort of intuitive too, right? You can sort of guess that's what's going to happen. Is that right? Because angle B is greater than angle E and everything else is sort of same. Of course. Well, let me show. Does this make sense? Okay. So we have a name for this theorem. Okay. And the name of this theorem is called side angle side. Well, didn't we have side angle side theorem? This one is called? Yeah. That's correct. It's called the side angle side inequality theorem. Because one of them is greater than the other. Is that right? Does that make sense? You see AC is greater than DF? So this is called side angle side inequality theorem. Is that okay? So let me show it to you right now. There's the name of the theorem. Of course, to describe this, unfortunately, to describe this, what we have here, it takes more than a couple of words. So this is what it's. But the idea is really simple. That's why I showed. That's why I didn't show it to you. Yeah, look, the idea is right. You have. Yeah. So who wants to read this? Go ahead, Austin.
If two sides of one triangle are congruent to two sides of another triangle, but the included angle of the first triangle is larger than the included angle of the second, then the third side of the first triangle is longer than the third side of the second triangle.
Good. And really, this is a simple idea, isn't it? It's just to describe this idea. It sort of takes a sort of long sentence. So write that down at least once. And aren't you glad we have a name for this theorem?
Yes.
Okay, so it's got a name, side angle side inequality theorem. And this is different than side angle side theorem, isn't it? Side angle side theorem is what, guys? That's when the two triangles are congruent. This was not saying the two triangles are congruent. It's saying AC is greater than DF. Is that okay? All right, so I'll wait for you to write. But the idea, again, is simple. So, of course, proving is the fun part, right? Right. Okay, so how would you go about proving this? Well, there are many ways, and it's not so obvious, okay? And you may think, how did they come up with this proof? But, of course, did they come up with this in just in 1 second or something? Or did they really study this and sort of figure out which ways? Yeah, it's trial and error, right? They try many different ways and they came up with this, okay? So you may think, well, how did they come up with that? Well, they really thought about this problem and they said, oh, if we do it this way, it works. Okay, so let me show you how this works, okay? So what we're going to do is we're going to draw an auxiliary line as before. And we're going to draw this auxiliary line BZ such that, can somebody read this for us? What are they saying? How are we going to draw this BZ in this triangle? Go ahead, Kevin. How are we going to draw this? Oh, just read what it says. Draw BZ so that.
Draw BZ so that measure of angle Z is equal to measure of angle E.
Good. Stop right there. So by the protractor postulate, right, we could draw an angle that is same angle as angle E right here. Could we not? So we could draw BC so that it matches with this angle E. And not only that, there's one other thing we have to do. Then what? On BZ, what are we going to do? Secondly, Kevin, keep reading.
A, B, Z, take point X so that dx equals ED.
Good. So BZ, pick a point, right? By the ruler postulate, there's a point on BZ such that ED, right, and BX will have the same length. Is that okay? Is that okay?
Yeah.
That's what we're going to do. Now, can somebody then tell me something about the triangle BXC and EDF? As soon as we do this, draw this auxiliary line BZ so that the ZBC has same angle as E, BX is same length as ED. Oh, a lot of you see it. Go ahead, discuss with the group. What do you see? Go ahead, tell them if you don't see it. So, Amen, what did you guys decide? As soon as we draw this auxiliary line like this, what can you tell me about triangle BZC and EDF? They're congruent. Is that easy? Why? Amen. Side angle side. Doesn't side angle side tell us that the two triangles are congruent? Of course, if two triangles are congruent, what can you tell me about XC versus DF? They're congruent by corresponding parts of? Okay. Now, let me ask you something. Okay, so that's great. We know that the two triangles are congruent if we draw an auxiliary line this way, and that XC is congruent to DF. That's good. But does it look like this every time? It says case 1. Would the X be on AC every time you do this? No, it doesn't have to be, right? It could be, but does it have to be like this? No. What's the other case then? If this is case 1, what's the other case? Tony?
X is not on AC.
Yeah, it's not on AC. Does it could also, it could be inside the triangle or outside the triangle. It doesn't matter, right? There are two cases, either case, right? X will be either on AC or it would not be on AC. Does that make sense? So if X is on AC, it turns out this is case 1. It is easy to show that AC, isn't that what we want to prove? AC is greater than? What are we trying to prove here? AC is greater than DF. It's easy to show that. Okay, if X happens to be on AC. The way to do that, anybody see how that's going to work out? This is sort of the trivial case. If X is on AC, okay, which doesn't guarantee that it will be, but if it is on AC, then it's easy to show that AC is greater than DF. Yeah, try it.
So, AX plus XC.
Exactly. AX plus XC is what, guys? AC, isn't that right? So if XC is equal to DF and you add something to XC, guess what? AC is going to be greater than? DF. What's the reason? Who could tell me first of all, what's the reason for AX plus XC, what is that? That's AC because that's segment addition postulate. Now, that's great. Now, what about then XC plus AX greater than DF? It's because of, yes, a property of inequality. Right, look, XC is equal to DF, correct? Now you add, like, if A is equal to B, and you add A plus C, what can you tell me about A plus C versus B? If A is equal to B? Austin? Remember property of inequality, right? If A is equal to B and C is greater than 0, AC is greater than what? B. So look, think about XC as A and then DF as B, right? A is equal to B, right? And now you're adding length to A. So A plus C will be greater than B. Does that make sense? So that's trivial case. So any question? That's case 1. That's what they're saying here. Does that make sense? Now, the more interesting case is if X is not on AC, either inside the triangle or outside. It doesn't really matter. Okay? Does that make sense? So then how would you go about proving that case? Well, let me show you right now. And like I said, this is not something that you could just come up with it, right? Come up with really in seconds, okay? They actually thought of this, okay, for a long time, and they go, okay, if you go this route, you could actually get this right. So let me show you. So here's case 2. Case 2 is, here's a picture of where X is not on AC, right? This time it happens to be outside the triangle. Does it have to be outside the triangle? No, it could be inside the triangle, right? Depending on what kind of triangles you have. Does that make sense? But that's not the important part. But what's important is that X is not on AC. If that's true, we're going to draw another auxiliary line. Do you see the blue auxiliary line right here? BY?
So
How do you...
3 more auxiliaries.
No. Just one more. We had the red one right here, Austin. And then I see. The other two? Yeah, don't worry about those yet. So we're going to draw by right now. Okay, is that okay? And if I draw by, how am I going to draw this by, by the way? Do you see by, the kind of give you a hint. You see this mark right here and then this tick mark? This is, by is going to what, Tony? What is it going to do? It's going to, exactly, it's going to bisect the angle ABC. Is that okay? Could we do that? Yep. So we could draw this bisector so that it hits AC at Y. And if that's true, so that's our second auxiliary line, right? The blue one. What can you tell me about this triangle? BAY and BXY. The two triangles are congruent. Why? How about, hold on. Why would the two triangles, the small one, BYA and BYX be congruent? Yeah, by side equals side. Isn't that right, guys? Look, didn't we say BA is congruent to BX, right? Which is congruent to ED. You guys remember that? Yes? And so we know that BA is congruent to BX, right? That's really given, right? BA is congruent to ED, right? And remember how we drew BX, right? BX has to be equal to, congruent to ED, right? So that's, those two sides are congruent. The angles are congruent. They're sharing the same side. Is that okay? So the two triangles are congruent, okay? Also, what do we know about XC and DF? They're congruent to begin with. Remember, that's from the very first auxiliary line we drew, right? Because of side angle side again. Remember, BXC was congruent to EDF. Okay, so that's great. So let's take a look at these. First of all, let's take a look at these two triangles. We know those are congruent. So what can you tell me about AY and YX? That's kind of easy too. Michael? What can you tell me about AY and XY? They're congruent, right? Because you have these two triangles congruent by side angle side. Is that okay? So that's fine. So then what they're going to say is, are we okay so far? Take a look at this triangle, this YXC. Do you see this triangle YXC? Right? Let me ask you this. What can you tell me about the length of XY plus YC versus length of XC in this triangle YXC? They're congruent? No? No, I'm talking about XY and YC. If you were to add XY plus YC, what can you, it's going to be greater than XC, right? Why? So here's what we, no. Why would this is saying, why would XY plus YC be greater than XC? I want you to discuss with your group. Go ahead, I'll wait. Okay, now that you had some chance to talk, let me see. Josh, you guys don't know why? Why the Y plus X plus Y, XY plus YC be greater than XC? Josh, what do you know about if I were to add two sides of a triangle? Yeah, it's because of the triangle inequality theorem. It's been sitting right up there. It's been right up there. Right? It's because of the triangle, right? Inequality theorem. What does it say? What's more important is what does it say? Even if it says there, if you don't know what it means or what it says, it doesn't really help you. Grace, do you remember what triangle inequality theorem told us? Right, you add any two sides of a triangle, it's got to be greater than the third side. Isn't this what we have, Iveta? Right? So XY plus YC is going to be greater than XC. And you may say, why are they saying that all of a sudden? Right? That's obvious. Why would they need that? Well, because what do we talk about XY versus YS, guys? I mean, XY versus YA, not S. XY versus YS. They're congruent. So instead of saying XY plus YC, what can I say? AY plus YC is greater than XC. Would you not agree? No. Could we say this? By substitution. Right? We had, Austin, you got this, right? XY plus YC is greater than X. So instead of XY, I'm just going to plug in AY because we knew these two small triangles were congruent and these are the corresponding parts of congruent triangle. Yeah, and what is AY plus YC, guys? AC. Right? So we could also say AC is greater than XC. Isn't that right? Right?
Well, that's a long story.
Well, that's actually, but is that what we wanted to prove? No. What do we want to prove? Who remembers? After all this, what is it that we wanted? Two people remembers? Three? Josh, what is it that we wanted to prove? AC is greater than DF. Iveta, so how are we going to show that AC is greater than DF? Not so sure? I want you to talk to your group. Go ahead, everybody. I'll wait, guys. So, Iveta, were you able to figure out what we could do next? So we know that AC is greater than XC, but that's not what we wanted to prove, right? What can we do next? So that we get to prove what we wanted to prove. Right, so we said that we know that AY is congruent to YX, right? So now, Iveta, we want to show that AC, and from there we know that AC is greater than XC, right? I mean, AC is greater than XC, yeah, right? But is that what we wanted to prove? No, we wanted to show that AC is greater than DF. Is there a way to go from here, AC greater than XC, to AC greater than DF? How? Say it again? Not quite. Let me give you a hint. What do you know about XC versus DF? They're the same. They're congruent, aren't they, guys?
Yeah.
So, Iveta, if XC is congruent to DF, what can you say? XC is, of course, then greater than DF by substitution. Isn't that right? Why substitution? Because we knew that AC was congruent to DF. AC was equal to DF, wasn't it? From the very beginning, when we drew the auxiliary line BZ, isn't that how we constructed so that triangle BXC is congruent to EDF? Remember?
No, I understand that, but why isn't it transitive?
You could write transitive, same thing, but right
You
now,
said you can't write transitive.
for here, how is it that we could write? Yes, you can. Why? Hold on. Why is it okay to write substitution here?
Because you're
These are?
measured.
Yeah, so transitive, you could use transitive for measured also. Transitive is used for measure and congruence. Remember? Substitution is the only one that's used for measurement. You guys remember that? Okay, so does this make sense?
Yeah.
Do you see why AC is greater than DF now? Josh, you had a question.
I thought substitution was equal.
Yeah, equal to. These are equal to, right? Isn't AC equal to DF? The length of AC, XC equal to DF. No, are we actually, okay, so are we using substitution for inequality? That's a good question. Is that what we're doing? No. In place of XC, what are we plugging in? DF, the one that has the same measurement. We're not replacing the inequality symbol. Does that make sense? Okay, so we're just replacing it. And that's all we're doing. Because they have the same measure. Is that okay? But do you understand? What's more important is that do you understand why AC is greater than DF now? Do you see how they did this? Right? Does this make sense? And they did many of these things and they figured out, right? By doing it this way, you could actually show that AC is greater than DF. Any question? Are we good? Yes.
Is it given that AB is congruent to X?
Right. AB is congruent to X. Which one? We know that XB. Yes. Because remember, if you look at the very first time, look up here. How do we draw the auxiliary line? We had BZ, right? So that what? Look what it says here. BZ so that this angle is congruent and what? BZ, you have a point X so that what? X is equal to ED. Right? And remember what ED was? In the very beginning, ED was congruent to BA to begin with. So by transitive, all three, this one, BX and ED, AB, BX and ED were.
Cases are the same group.
Yeah. But of course, am I going to ask you something like this for your test or something like that? No, but it's a good idea to actually go over these things and understand what the theorem is saying. Do you understand what we're saying here? Okay, any other question? These are good questions. Do you understand? That's a good question, okay? You understand why? Those are yes, Kevin.
So when you use substitution property,
Right.
you could put transitive,
Yes.
like always.
Yeah, transitive property of equality. Right? Not congruence. Okay? But not the other way around. Right? For something for transitive, you can't use substitution. Because transitive works for equality and congruence. Does that make sense? Substitution only works for equality. Does that make sense? Okay, yes?
So that's the proof for
Yeah, this. Right. Because we had two cases. May I move on? All right, good. Now take a look at this and let's see what you could conclude from here. I have two triangles again, and I have AB congruent to DE, BC congruent to EF, just like before, right? But now look what I have. I have side AC greater than DF. What can you conclude if this is what we have? So this is not the same as what we had before, right? Similar because of the first part of the given, but the second part is not the same. So what can you conclude here? Chris, what do you think? In terms of these angles, angle B and E. Yeah, angle B is greater than angle E, right? Would you not agree, guys? So, right? That's what happens. This is always true. Okay? Guess what? This is another theorem and it has a name.
Is it long?
No, it's not ASA. Anybody want to guess? Yeah. No. No, I don't want to give you all the bad ones. It's called side. Side, inequality theorem. Okay?
Oh, dude, that's long.
Yeah, again, it's because it's describing this
Well, how can you not fit in
given, right? But it's really simple idea, isn't it? Right? Just sort of long to describe it. Who would like to read this for us? Go ahead.
Me?
Yeah.
Yes. Two sides of one triangle are congruent to two sides of another triangle. The third side of the first triangle is longer than the third side of the second. But the included angle of the first triangle is larger than the included angle of the second.
Right. The idea is not hard. It's sort of right long to describe this whole situation. So thankfully, aren't you thankful that it's got a name? It's called side inequality theorem. Is this same as side theorem?
No.
No, very different. Okay, side theorem is that's a postulate, I think. That is two triangles congruent, right? This one is different. Side inequality theorem. Okay, so write this down. I'll wait. So again, of course, the fun part is to prove this theorem. This time we're going to use proof by contradiction. Okay. So who could tell me the first step for this? Actually, this is a lot easier if you do it by proof by contradiction because of what we've been doing so far. Okay, Yechan, what's my first step?
Assume temporarily that measurement angle B is less than or equal to measurement of angle B.
Good. Measurement angle B is less than or equal to, right? It's just not less than, is it? That'd be wrong. It's less than or equal to measurement angle E. Would you not agree? Then you get two cases again. What's our first case? Yes, sir.
Angle B is equal to.
Good. Angle B is equal to angle E. What's the second case? Yes, sir. Check. Measurement angle B is less than measurement angle E. So let's start with the first case because first case is really trivial. Brandon, if I make or assume temporarily that measurement angle B is equal to measurement angle E, what can you tell me about AC versus DF?
AC would be less than DF.
If measurement angle B is equal to measurement angle E?
Oh, they would be the same.
They'll be the same. Why? You're right, Brandon.
Because if two sides are congruent, if two sides are larger than the other.
No. You're not. Okay, so if angle B and angle E were congruent, were equal, right? What do you know about these two triangles? Those two triangles are congruent by? Yeah, side angle side, right? Side angle side. So therefore, AC will be congruent to DF by corresponding parts of the triangles are congruent. But guess what? That is the contradiction to the given information, which says what? AC is greater than DF. So that's. I'm sorry.
How'd you get that they're congruent?
Okay, so Andrew, if I assume temporarily, I'm using the proof by contradiction here, right? If I assume temporarily that angle B is equal to angle E, you know that the two triangles are congruent. Isn't that correct?
Yeah.
By side angle side. Well then, AC is congruent to DF, right? Well, that's a contradiction to the given info that AC is greater than DF. Right? Now, that part is, so that's easy. Okay, case one, okay? So there's your contradiction, AC equal to DF, right? You see? That's the contradiction to given. Now, what's more interesting is if I let B then less than E, how are we going to get our contradiction? What happens as we assume temporarily that B is less than E? Okay, everybody discuss with your group. I'll give you a couple seconds. Brianna, what did you guys come up with? If we, as soon as we let B less than E, what happens? Yes, AC is going to be less than DF, right? Why? Yeah, which theorem? Yeah, side angle side inequality theorem, the one that we just proved, right? If as soon as B is less than angle E, right, we know that the side opposite of, right, that one is less than this one. But isn't that a direct contradiction to what's given here? We said AC has to be greater than DF. Now we're saying AC is less than DF, right? That's the contradiction to given fact, right? Therefore, temporary assumption must be false. That follows what?
That measuring angle B is greater than measuring angle
Measuring angle is B is greater than angle E. Any question? Okay, let's do a couple examples real quick. Okay, these are really simple examples. Look up here. So here is example 1. If I told you that RS, that's given, RS is equal congruent to RT, and measure angle 1 is greater than angle 2, what can you deduce? Whoa. Ratio. Okay, how about Esther Yoon? What can you deduce if this is what we have? You. Go ahead. We know that SR is congruent to RT and 1 is greater than angle 2. What can you conclude if that's true? I'm sorry? Which one is greater? Yes, SV will be greater than VT, right? Because they're sharing the same side, RB. What's the reason? Class? Side, angle, side, inequality theorem. Very good. Alright. Does that make sense?
Yeah.
Let's do one more. We're almost done. So what about this one here? If I know that EF, right down here, is congruent to EG, the segment, and DF is now greater than DG, what can you deduce? Everyone should know by now. Just 2 people? If EF is congruent to EG and DF is greater than DG, what can you conclude here? How about somebody that Naomi? Okay, let me give you a hint, Naomi. Isn't DE congruent to itself? So you have this DE congruent to DE, EF congruent to EG, and this side, DF is greater than DG. What can you tell me about angle DFE versus DEG, Naomi? Yeah, DEF, DEF versus DEG. DEF is greater. Why? Because of side inequality theorem. Isn't this what we have? Right? You have 2 sides congruent except the third side is greater than the other. Therefore the angle, right? Opposite angle of the greater side is going to be greater than the other one. Does that make sense? Any question here, guys? Can you do something like this for your homework? Yes. Okay.